Welcome to the lecture series on object-oriented analysis and design. It is a very important topic we are going to talk about today, namely the object-oriented database management systems. Data is something which is very essential to every business, every work, every endeavor which we undertake. However, defining precisely what is the data that will really make things happen has been a serious challenge. We made it very formal, we made it very intellectually stimulating exercise when we started asking what is a well defined input data that gets transformed into a well defined output data. This is the genesis of programming, this is the way we have been progressing. We do know that for any welcome to the lecture series on object oriented analysis and design. It is a very important topic we are going to talk about today, namely the object oriented database management systems. Data is something which is very essential to every business, every work, every endeavor which we undertake. However, defining precisely what is the data that will really make things happen has been a serious challenge. We made it very formal, we made it very intellectually stimulating exercise when we started asking what is a well defined input data that gets transformed into a well defined output data. This is the genesis of programming, this is the way we have been progressing. We do know that for any functionality to happen, it is necessary to understand that what is it that is going in as data, what should get represented as data takes time. It takes time to understand what is that data that aids the business in a manner where at so and so point in time we see a good return on investment or whatever is our success parameter. So, we therefore said that there will be data in every business and it gradually increases to a point where we see that a historicity about the business will tell us so many things about how we do business, how we should progress, what is the next step it tells. Well, whether we want to believe in data based decision making or not is something that is secondary to us. Good businessmen always keep telling that we rely on instincts. It helps bring the facts to the table, every transaction becomes helpful. Otherwise, all of us are only hitting in the dark most of the time, or we are talking about an abstraction which we do not have a grip at the time when we are beginning to understand what we want to do. We want to do something new, how will you know? Therefore, we have gotten accustomed to the fact that while instinctive, insightful, intuitive business decisions have been successful, most of the times we take a safer path for many by looking at what is it that has been driving the business as data. Not away from people, but we keep telling that something that we have been doing as people is captured as data and that drives the functionality. The same thing we try to do in programming, the same thing we try to do, keep doing in software engineering. Data is thus something which we have elevated it to a plane of intellectual discussion, and what we did was we do talk based on facts. This is bring the facts, just go ahead and then process it. That is how we have been talking about. So, the database management systems began to become very important, because if it is only limited number of data, few weeks of data, we can always remember. I have seen people who can simply reel off something like 1,000 visiting cards details very quickly. Those used to be the skill sets at that point in time, until we started talking about putting all these visiting card locator in a database. They do it very quickly, they sort it out, and then most of the time they are very quick. Only on a table around 1,000 cards will be there, they will pick it up. It can happen, we are not denying, we are not disputing. It is not to replace the human being at all, but to create space for many human beings to spend their time on better and more creative endeavors. So, we got the same idea into the businesses. Data is there. If it is large data accumulating, we need some piece of software, that is what we called database management system. How do we organize this data? I mentioned it a few minutes back that you can have 1,000 cards sorted out in some kind of an alphabetical order or whatever it is. Very quickly it is retrievable, and they do it almost out of memory most of the time. They can pick where the card is and tell this is how it is. It used to be a nice way of getting some leads, contacts. It's a kind of consultancy which was thriving. I was very young and in Chennai at the Madras at that time. It was a thriving business. They collect a lot of cards, keep them. If you go and consult them, they will tell you, please go and contact so and so person. It's something which is which can be a sort of a lead. History of data models. Then what we said was, if it is just like that, it's becoming a bit of a cumbersome exercise, because our data is though structured, fully structured, well defined. The formats will still manage, different visiting cards look differently, but then the entire exercise, what is this fellow trying to do when locating the card of my choice, putting the card of something, putting a card that has come, that is not too clear. So, what we did was we banked on the same old methodology of model. We will have a model, we will start telling that all these ideas around data will be structured, fully structured, rigorously structured, and they will all be built in some hierarchy. So, what is the meaning of it? If I have to find a detail, we have to go down the fourth level. It is like a tree structure, the root is there, subjects are there, you please go to a library, library is at the root, you have to go to the library. In the library there are sections, mathematics, physics, chemistry, biology. What do you do when you want to get a biology book? You have to go to the biology section. By doing so, you are completely negating in your mind mathematics, physics and chemistry. The other sections, but just to give you an example, library is there. That is our data model. In our mind, that is the model, because that is organized like that. We can always get a million books stuffed into a building. What is the reason why we want to organize? Retrieval should be faster. So, if I have to go to a biology section, I will simply go to the biology section, and in that point in time I am completely negating mathematics, physics and chemistry in my mind. That works like that. In biology, what are we going to look at it? Maybe bioinformatics, that is one subsection, we will go to that rack. In bioinformatics, what are you looking at? Some book which I know, probably you will get it. So, we said that this is a good idea, a simple way in which we can organize what we are doing. Traditionally, that is exactly what has been happening in science also. We have divided it into domains, and then we said at some point in time, if need arises, we will integrate. At a point in time when I am reading this bioinformatics, if I need mathematics, I will go to the mathematics. To some extent, we have our own late Professor S.R. Ranganathan, who has created this duodecimal system, where all those things are available in some place. You need not go directly to the rack, but then related things are all together. The model has changed completely, and till today we adhere to that model, the duodecimal system. So, the hierarchical data model was working like that. The next model, what is the problem with hierarchy? At a level where you are in, at a node where you are in, you are completely unaware of everything else that is happening. If we can structure a business with that kind of a clarity and focus, there is nothing like it. We will do exact at that point in time. Well, we are all researchers, we are not too sure. As I said, as you go and look at bioinformatics, if you need physics, you will have to go and look at physics. So, what we did was, as we progressed, as we gotten accustomed to the idea of organizing data, the model tells that in this case the data is organized like this. What does the network data model do? People who read mathematics, let us say for example, change it to mathematics, also need to understand a few other things. Mathematics is all like that, it has its own subclassifications, it has its own way of working. For example, those who are reading mathematics will also require these days what we call numerical analysis, which is in the computer science field. So, if there is a connectivity, natural connectivity, we will lead some pointer saying that maybe it will be useful to do some numerical analysis, and we started talking about the numerical analysis which was done by inspection became computer oriented numerical analysis. We have been talking about all these variants. Today all these are nicely put together, as you would know, they are simply calling it data analytics, which began like this. We should have an organization of the data, we should talk about that. So, hierarchy was restrictive in the sense that you become very focused, almost forgetting any other possible related data items that you need to know. Networking will facilitate, it tells you that you can go on this network, you do not have to go all the way down to level 3 and climb up to the root and go elsewhere. You can go to level 3, and in level 3 we have anticipated that you will know, you need to know level 2 chemistry, you go there and do that level 2 chemistry, it is already networked. There was a very nice point that was made at the time. These are very valuable lessons in managing data, because eventually data will start dictating, because that is the best safest method. If all of us are talking about verified data, verified facts, it is easy, there is no concern, and therefore, what is the concern that we are talking about? How to manage, how to navigate towards this data, and we do not want it to be a data dump. That was our idea. Today it is, but then we are not calling it a data dump, we simply use a nice word saying that unstructured, the data is completely unstructured. But then in the beginning we were never too clear as to how to deal with that grade of unstructuredness in the data. So, we brought all of that into some kind of a model, a structure. Hierarchical was the first, network was the next. The third one is a relational database model, which was appealing to us because we do not want to know too many things about this object. To operate, all that I need to know is there is a monitor, the attributes are there, the computer facility here, as far as I am concerned, is only a table. It has a monitor which is called Wacom, it has a keyboard which is called Dell, and whatever it is, different brands are there, different equipment is there. So, what we are talking about are a simple representation mechanisms which relate to us. Again we are coming close, as I said earlier on, we have been using the entity relationship model in object identification at so many places. So many places we have been using the table, we have been talking about in verification and validation. At all places we said there must be a relational database model. We know this object is independent, there is something called one object here which is a makeup material, and there is a pen that I am talking about which is used to point at the screen. Both of them are relatable to whom? Relatable to me. How do I know that? Because the data model says this is separate, I am separate. For that point where I am using all of them together, this is what is possible. I can use some makeup elements, use this pen to point out at the screen, the lecture goes on, and both are now related to me. Until now they were not related to me, they have no concern about me. Now I have come, I want to do something, they have to be related. So, I can in theory strike relationship whenever I want, in whatever manner I want, but then what is the crux here? Are we working correctly? The same story, whether we are doing the object identification and modeling correctly or not, manifests again. So, we said let there be an entity relationship model which is bound by a nice mathematical idea called calculus, relational calculus, a tuple calculus, and then based on that tuple calculus we will automatically retrieve. It is not putting something in, but getting something out of it whenever we want, in a manner where when we ask a question, why should I believe it is correct, it is correct, it is verifiable. So, it is a relational database model. Then came the next one saying that it is called semantic data model. So far it does not make any meaning to me, it is just one entity which is there. There is no semantics associated with that to a point where I keep telling that it makes meaning to me only when it is on and it is connected to a mouse and it is connected to another screen which is showing everything opposite to me, and then it is connected to a studio. It should be automatic. However, they are all independent objects. If you want, you can use these objects independently, but then there is something called a semantic associated with that. It makes sense to me only when it is serving a purpose. On its own it is there, I do not know what they are doing. My good colleagues here may be doing all the PowerPoint presentations, which they do very nicely for me. Even at a short notice I can get the things done. So, the essence of relational database is the data is represented like this, but do you see them like that in your mind? The answer is no. It has taken away that representation of an object in your mind and put in some form which is like that, which is good, but then it works only through the database management system. But if you create a semantic, it relates to me. If I see the books on the rack, I may get an idea of picking a book. Something looks familiar, I can go and find out what it is all about. But if it is just like this, even in a catalog, it may not occur to me that it is a very familiar book. The author's name I know is different, Aho, Hopcroft and Ullman. That is what I look now. It is completely different. All three people wrote that book, but it appears like this. It is appearing only in this manner. Title is compilers, compilers, compilers. Actually, it is a 3-author book. Now you see the semantic. Semantic is absolutely essential. John Hopcroft, Aho and Ullman. So, it is something that we need to understand. In my mind, it is compilers by Aho, Hopcroft and Ullman. If I see it like this, it is good for the machine, nothing wrong about it. All ISBN numbers are the same, keywords are the same, publisher is the same. There is adequate reason to believe that it is perhaps the same book that I am thinking about, but at a quick glance it does not appear. It is 6 books in the catalog, whatever duodecimal system it is, whereas what I am carrying in my mind is a book called Compilers by 3 authors, Aho, Hopcroft and Ullman. So, we have had these difficulties when we were forcing a structure. No structure is complete, no structure is correct to the purpose of every individual. It is not satisfying all individuals. Similarly, there is no model which is correct, but they are all useful. Therefore, what we did was we started like this. Now, we wanted to give some flexibility, saying that we will create one more table. These are similar books. So, if you are touching on one of these 6 entities, you will automatically go, the database management system will show that please note this book has 2 other authors. Any one you choose, it should tell it has 2 other authors. Is this the same book that you are looking at? Things that we are experiencing, things that are happening today. Online shopping is very common. We must acknowledge that Amazon pioneered this exercise. It started with the books and then now it has expanded. It is doing very many things. Redundancy in design is forced by the fact that we cannot have set valued attributes. So, the attributes are in this manner, and when we talk about a combination that is suddenly necessary, some set has to be created for these 6 books, that has to happen as a separate table, and we keep telling that there will be lot of redundant information, it will occupy more space. So, what did we do in the typical relational database? We simply said let us have 3 tables. Then automatically you will know, if I am searching on compilers, I will find out 0210 also has 3 authors, it has the same keywords, keywords based, author based, it is all together. We should give an idea, but still I am not imagining the book. What I went into the library is to find out that whether I can borrow a book by Aho, Hopcroft and Ullman, compilers. It is something that is in my mind, it still does not relate to that object in my mind. It is good to talk about a free entry into that also we do. Most of the times when we go to the library, researchers typically think some abstract idea is there, like keywords. I am looking for a good latest research paper in the area of object oriented analysis and design. Anything is fine, but then how do I look at, how do I look up to? Well, gradually we said the problem is we are obsessed with the structure. how much structuring you do, how much modeling you do, you will never get that semantic connectivity, and the closest we come is move to object oriented. So, what we did was the object book has been split over different relations. It is in 3 tables and I am still not able to put them together. So, we keep telling that how do you relate the tables? There are keys, everything is artificial, because what is natural to me is a book, title, compilers, authors 3. Artificial keys are introduced when modeling set of sets. Cars can be bought with certain features, air conditioning, leathers, for each car various packages, nothing can be imagined together. So, it becomes something like that. Imagine that you are doing some online shopping of the car, the chassis, these are the chassis colors. Next, these are the possible steering wheels, these are the possible air conditioners, these are the possible leather sets. How difficult it will be to imagine, visualize what is it that is going to be when everything is put together. How much ever business intelligence you want to put in, saying that all air conditioners do not go with this car. When you choose this car, the chassis is like this, only these air conditioners are valid. You can create more tables, but then the collectiveness of an object is still not appearing. Leather seats are like, for each car various packages of these features are available, each package being a particular set of features. No natural support for complex queries, print all books co-authored by J.D. Ullman and A.V. Aho. So, well, we said the structure alone is not going to be helping us in the way we are working. We will create a query language. Structure is one that takes time. On top of it, we have some flexibility of navigating across all these tables. Automatically, they are not giving me a semantic connect, but then if you have SQL, structured query language, then we said that query language will allow you to express what you are looking, which is not natively seen in the structure of the table or the model which we are using, but we have the database management system process your query and tell you these are the things that are there. What is wrong with this? Everything is fine except the fact that the table size itself is very restrictive. It is a cumulative sum of its attribute size. Suddenly you have one image as an attribute, it becomes very difficult to have that entire, let us say, a maximum size of 10 kilobytes. Those days kilobytes was a huge exercise, very big exercise. I was teaching using DBase 3 plus, which is a reasonably well graded relational approach to databases. There are my own good colleagues who never wanted to classify it as an RDBMS. We have those Puritans who talk about what should be called RDBMS. This is a good DBMS. DBase 3 plus was a package which was there to teach. I was teaching using that. So, DBase 3 plus is there, nothing wrong about it. It is a very good organization, very good brand. Everything is fine, lot of people were purchasing, it is a very popular package. So, it gives you a feeling that it is in adherence to that relational database. You have created a table, only 10 table entries are likely to have this 10 kilobyte requirement, whereas the table size is 150. So, we know for sure that only 10 records will have that 10 KB space requirements, the other 140 do not require, but if you define that as an attribute and say that 10 KB should fit into that attribute space, we are wasting 140 into 10 KB of space. Space was at a premium, memory was at a premium at that time. So, these objects we started talking about as complex objects. What is it that we have done? This was a serious problem. The genesis of Y2K problem is simply put like this. They did not want to have 3 fields, month, day and year, fully knowing the month will never be more than 12, the date will never be more than 31, the year will not be more than 4 digits. Therefore, to represent 12, 0 to 12, how many bits do I need? 4 bits. For 32, 5 bits. 5 plus 4, 9. If we have something called a 16-bit position, we will simply tell remaining 7 bits we can use for year. If you do not do that, you will have 24 bits, because each one is 8 bit, 8 bit, 8 bit. For day you will use 8 bit, whereas you need only 5 bits. For month you need only 4 bits, then why are you using 8 bits? For year it is enough. So, if you have them as 3 separate attributes, 3 separate fields, it will be 8, minimum is 8 bits, 8 bits, 8 bits, 24 bits. If you condense them, it will be only 16 bits. 1 byte saved with so many records, million records, is a huge saving on the storage space. So, we started like that until what is the problem? The problem is when the year is changing to 2000, we have to reset. People did not want to have 4 digits, 4 digits kept for the year, 2 is enough. Then what will happen? 4 for day and 5 for month, and 100 what will we do? Maybe 7. So, 16 bits, you condensed everything in 16 bits, everything is over. So, but then what is the disadvantage? 1900 is 00, 2000 is also 00. So, we started economizing. The obsession with the structure was so much and the limitations of the memory space is so much that we started economizing, packing as much as possible in a single attribute. One place where we were certainly expected to be hit and hit harshly was this date change. 1900 is 00, 2000 is 00. Therefore, what do we do? How do we distinguish that? It became a very serious concern. It was anticipated, Y2K was anticipated, it did not take off as much. Whatever has happened has happened. They came up with some half a dozen solutions to do something called a sliding window kind of a method, so that we can easily spoof over what is the date that needs to be addressed and manage it. Often objects are like this, become like this, they make their presence felt like this: binary large objects. The object is large, but not all records require that object to be stored. So, we leave a pointer there, it becomes a very complex object. Whenever it is needed, only those records where that pointer is available, we will get it, otherwise it is not there. Your photo is there, not there, it is not there, the pointer blank is, the pointer field is blank. As a video, these days, we are talking about storing personal data with a voice script. It is not enough to have your biometrics, you should also give a voice script. As we see, we will understand as we progress, you should also give a voice script, voice addressed. So, the point is, the more we have, the more we want. That is the very nature of technology, and it has pushed. Data became the lifeline, data is the lifeline of many decisions. Even though we give lot of value to what are called instincts, intuition, and the way we talk about what is called the nature of business, which is thriving on insight, we keep talking about it. However, most of the people in the organization are much more adept at talking data, everything based on data facts. Behavioral data, distinct objects may need to respond in different ways to the same command. Here we are talking about a simplicity. If the pointer is there, it will fetch. It may be a video clipping, it may be anything, very quickly it will fetch. If it is not there, it is not there. Now, if I fetch, it should appear in one manner. If my colleague in this block fetches, it should appear in another manner, because he has a better access. So, he may need something else. The object is not simply large, but it behaves differently for different people, differently for different queries, differently for different combination of the other attributes. So, we started talking about semantics, which is again akin to object identification and modeling. Thank you. We will meet in the next lecture.